Without using a calculator, solve each equation for x. In part A, we're asked to solve the equation 10 to the x minus 5 is equal to 1,000. So we need to think 10 to what power is equal to 1,000? Well, 10 times 10 times 10, or 10 cubed, is equal to 1,000. So let's write 1,000 as 10 cubed. So the only way that these two expressions can be the same is if their exponents are the same. X minus 5 must be equal to 3 because both exponential expressions have the same base. Now add 5 to both sides and we get x is equal to 8. Let's double check and make sure that it works. 8 minus 5 is 3. 10 cubed is 1,000. That checks out. In part B, we're asked to solve the equation log of 2x plus 10 is equal to 2. To solve this equation, we need to understand the meaning of logarithms. Let's do just a few examples. What is the logarithm of 10? Well, a common logarithm is a power of 10. So we have to think, what is the power of 10 that produces 10? Well, we know that 10 to the first power is 10. So we can write this as log of 10 to the first power. The exponent of 10 is 1, so the logarithm of 10 is 1. What is the logarithm of 100? Well, what we need to ask ourselves is, what is the power of 10 that produces 100? Well, 100 is 10 times 10, or 10 squared. So we can write this as the logarithm of 10 squared. And the exponent on 10 is 2, so our answer is 2. One last example. Suppose we had log of 1,000. We would have to think, what power of 10 produces 1,000? Well, we know that 10 times 10 times 10 is equal to 1,000, so 10 cubed is equal to 1,000. And 3 is the power of 10, so the logarithm of 10 cubed, or the logarithm of 1,000, is 3. So let's take a look back at our equation. We have log of something is equal to 2. What does that number have to be? Well, over here we see that the logarithm of 100 is 2, so the number, or the expression, the argument of the logarithm must be equal to 100. So we have 2x plus 10 must be equal to 10 raised to the second power. 2x plus 10 must be 100. Take away 10 from both sides, we get 2x is equal to 90. And divide both sides by 2, x is equal to 45. Let's check. Does it work? 2 times 45 is 90. 90 plus 10 is 100. And the log of 100 is 2. It does check out. For part C, we're asked to solve the equation 10 to the 3x minus 1 is equal to 0.0001. In part C, we're asked to solve the equation 10 to the 3x minus 1 is equal to 0.0001. So for this equation, we'll use a similar strategy to what we used in part A. We're thinking 10 to some power is equal to 0.0001. Well, this decimal is 1/10,000, so we can write this as 10 to the 3x minus 1 is equal to 1 divided by 10,000. But 10,000 is 10 multiplied by itself 4 times, or 10 to the 4th. So we have 10 to the 3x minus 1 is equal to 1 over 10 to the 4th. But 1 over 10 to the negative 4th is the same as 10 to the negative 4 power. So we have 10 to the 3x minus 1 is equal to 10 to the negative 4. The two exponential expressions have the same base, so the only way they can be equal to each other is if their exponents are equal. So we have 3x minus 1 is equal to negative 4. We add 1 to both sides. 3x is equal to negative 3. Divide both sides by 3. X is equal to negative 1. In D, we're asked to solve the equation log of 500 minus 25x is equal to 3. For this equation, we'll use the same strategy that we used in part B. We have the logarithm of something is equal to 3. Well, we've already seen that logarithm of 1,000 is equal to 3. So the argument must be 10 raised to the power of 3. That is, 500 minus 25x must be equal to 1,000. Take away 500 from both sides and we get minus 25x is equal to 500. Divide both sides by negative 25 and we get x is equal to negative 20.